Yeah, so this is called MarkDoom. So it's how I hacked every major IDE in 2 weeks. And I guess the caveat there is I was specifically targeting IDEs that rendered previews for Markdown. So if you happen to view a Markdown file from a project you're looking at or some exploit or something like that, then it would render. So I guess the asterisk besides every is to strip out the people that say I didn't hack Vim or Nano or some other non-IDE editor. So who am I? I've been in application security for about 8 years now. I was a security consultant for a while, participated in a bunch of code review, architecture review, pen testing, and stuff like that. Currently, I am the director of security research at Contrast Security, and we develop IAST and RASP products. And I've been developing the Node agent for that, but focus a lot on vulnerability research and that sort of thing. As far as bounty stuff, I participate in the bounty programs now and then. I was really early on in Facebook's bounty program. Before they even had a bounty program, I was submitting bugs that would be worth a ton of money these days, but were free back then. But it's really great to see everyone moving towards these programs and being so successful. So what is the desktop web? So more or less, it's just desktop apps that have a built-in browser. And so there are frameworks like Electron, where it's the entire application is written in JavaScript and HTML, and it allows developers to really quickly, or web developers, make desktop apps out of things. But we're not limited to that. I mean, I found a vulnerability a while back in HipChat, and HipChat just has an embedded browser. It's just easier to render certain things, like a chat conversation, using HTML and JavaScript, or because you want to have emojis, you want to have video support, playback, and things like that, and to build that in a native app, and you want to have a web interface anyway, so building it more than once is just a hassle. So a lot of people tend to go to these things where I write it once for the web and then deploy it multiple places. And so that's kind of what we're looking at, but also embedded browsers. So just like a preview window in Eclipse or something like that. So when we're exploiting the desktop web, this is awesome because it's the exact same web techniques that we've used before. There's HTML injection, we care about CSP bypasses, like built-in API abuse, things like that. There's questions about like what is the same origin policy for, it's usually pulling in a local file, so local file is the origin usually, and what does that mean to your browser? Because these are embedded browsers, they're not like opening an HTML file in Chrome. It's some embedded browser. Even if it's Chromium, it doesn't have like some of the Chrome security policies. And more importantly, like JavaScript control or an XSS can result in remote code execution. So this is really great. I can send you a message in Slack, and if that Slack can inject JavaScript, can I control your computer from there, right? So really quickly, I'm sure everyone knows this because the Bug Crowd platform supports Markdown, but Markdown is just like text formatting, some simple text formatting that is super common on Bug Crowd, GitHub, Bitbucket, full blog platforms that use this. So I think the important thing here is that I've not found a renderer yet that parses Markdown to anything but HTML. And so take your Markdown format, you get HTML back, you inject that somewhere, whether it's in your ticket on BugCrowd or it's in your editor online for a preview. So why is it so hackable? This is a quote from a Markdown standard, from the standard definition of how to render Markdown. And so if something's not covered, if any formatting is not covered under Markdown, you simply use the HTML itself. And then so that means like if there's something like an iframe that you want to support, or if you just don't know what to do for a table or something like that, you can just write HTML. And most Markdown parsers just take any HTML after that and then display it. So combining that and thinking about like editors that allow Markdown preview and stuff like that. So who did it wrong? What apps were I able to get code execution on? So we have Microsoft's Visual Studio Code. It's able to get code execution on GitHub's Atom editor, Adobe Brackets, Eclipse, TextMate, which seems pretty minimal because it's just a plain text editor, but it had some interesting issues. JetBrains, all of their products, and I mean all of their products, had issues and issues at the core of the JetBrains engine. And then there are a lot of kind of no-name Markdown editors, but some of them are interesting because they were completely native apps. They weren't built on top of Electron. And some of these were payware, which made them kind of interesting as well. I mean, obviously JetBrains is also payware, but. So we'll start off by talking about Electron and the Electron engine. And so for those of you who don't know, Electron is basically just, like I said before, a web browser with Chrome, and it's a desktop app. You write JavaScript HTML, you have this renderer, and then you have access in that HTML to the Node API, and the Node can execute, like, read and write files, download stuff, do normal, awesome Node things. What editors use that? It's Visual Studio Code, GitHub, Brackets, things like that. And it really can't be this easy, but it actually was. So if you create a Markdown file, you put a script tag, and you can call out to the Node child process module, and then call the execute whatever, and then do whatever you wanted. So it really was as simple as just put a script tag in the case of some of these editors early on. So Visual Studio decided that they would embed CSP, so content security policy stuff. And they actually included some really interesting things as well. So CSP is injected, and then they have a catch for it. So if they see that you have a CSP violation, they pop up a window that lets you accept that violation and let you continue. There were a couple of issues with this, like this is rendered inside the same HTML as this other thing, so there were some boundary issues initially with that as well. But I thought that was really clever to be able to show and allow the user to click through some of the problems that they had. But there's a couple things that are important to know about CSP and dealing with this type of desktop renderer. And the first thing is the CSP spec doesn't prevent redirects, or if I click on a link to an external URL, that's expected and okay, even though that's not same domain or whatever else. And usually that doesn't really matter. But in this case, it does matter. So they're injecting meta tag at the top of the page that we're on for CSP, and then we can inject meta tag for refresh to leave. Another important thing to know is that when you try to use a remote network resource like SMB or NFS on OS X, it auto mounts, and then there's a guessable path for both of those different types, and we'll see that in just a minute. So this was a bypass for that. So we redirect for OS X, we redirect out to, because we're on the file, the quote unquote file origin. And so we redirect to a file at a known path now, and this file is under our control. So we don't redirect to a web page, but this is on a server that I run. And this path is always there. It's the IP address of the site you're gonna reach, and then the path from there. And then the exact same exploit continued from there. So we're basically just a frame in the windows. We're just an iframe built into that. So the final fix for them was to prevent any navigation away without popping the same warning. And then they also disabled node integrations. So in Electron, you can have a window that, and you can tell that window, I don't want it access, or any sub windows from there, I don't want them to have access to the Node.js core underneath. This ended up being exactly the same for Atom Editor. Really similar attack vectors. Adobe Brackets was actually slightly different because they have a little bit different, they're not actually Electron, they use their own bracket shell, which is the same idea as Electron, but they have a different structure for their plugins, and so the actual vulnerability was slightly different, but overall just as easy. So another interesting thing is abusing open in browser. When an app isn't Electron and you don't have access to the, a node shell, if you still want, or is it still possible to execute code? So it's interesting, if you have an app and you want it to open in the default browser, how do you do that? You have to figure out on the computer what the default browser is. You have to figure out, and if you have a cross platform application, that's really tough to do. So open in browser just doesn't magically work across. You have custom logic, and it's kind of a pain in the ass. So what people usually do is end up saying, like, I'll take this URL that you clicked on, and then I'll just hand it to the operating system and say, you open this URL. And if you have, if it's a URL and their default browser just picks it up because that's how it handles URLs. The problem is, if you give it a file colon path and you have access to file colon path because you're inside the desktop app, it will just pass this file path URL to the default open command. And the default open command is, the open command in OS X, or command.exe -a. And you see it just passed in the full URL as is. And usually you can't break out of that string or whatever, as far as I've attempted, but it will just, by default, open, or it'll run the default action for whatever that type is, for whatever that file type is. And this happens to be an application. So again, we have execution. This is not quite the execution that you expect because it's kind of only local files. But remember, we have access to quote unquote local files because we control a known local path now. But the files must also be executable, which these directories, they're not by default, and you can't have executable over the NFS and stuff. Or the default open type for the file might be executable. And so this was a fun trick where, so I'm using, this is an exploit in MarkDoom, but I'm using a .terminal file here. It's hack.terminal. So a terminal file is, in OS X, is the preferences and properties of your terminal. You can style them and do whatever you want to do. And then you can export those, and when you double click on them, it opens a terminal with that styling, with whatever you have in there. One of the properties you can set is a auto run command. So even though this isn't an executable file, it's not like a shell script or whatever else, its default behavior when opened is to start a terminal, and then if you set the startup command, it'll run whatever shellcode you have in your terminal app. So finding apps that execute code when opened as the default opener for an app is really awesome. And so this is great. This is like a non-executable file that executes code when double-clicked or when clicked on through a shell. But so we're using some trickery here to have the onload event click on the link. So this is automatic. As soon as you preview this file, it clicks on the link that it's inside. So yeah, just set a shell, export it, and then we're off and running. So the next one is abusing the JavaScript bridge. And so a lot of apps have a JavaScript bridge between their native code. So in the case of JetBrains, it's their Java application, and they set up a couple of functions. And the JavaScript preview window that you have, there's like a built-in bridge for that. And so in this case, it's kind of abusing the same open and external browser, but it's really crazy. I mean, as you start looking at desktop apps and you see like all of the things that they inject for you automatically, the things that they give you like external access to, is really crazy. But this open and external browser wasn't the same as clicking on a file. This was actually a more generous API that looked like it was left over. So TextMate also had a bridge, and its bridge had a textmate.system command. So that was a pretty obvious place to look and resulted in this pop-up, the cat data there. So I guess that could be seen there. So so now I think one of the last things I want to talk about is abusing URL schemes. So Visual Studio Code, again, to come back to it, when you start looking at desktop apps and how they work, a lot of them implement, if not externally, so like TextMate, Eclipse, things like that, they have these URLs that you can click on and it'll open your editor to that file in line. Those are great. Those are really great places to target. But if you dig a little bit deeper inside the application, there's ways that different windows communicate with each other. And those use URL schemas as well. And so as you dig apart an app and look through its internals or look through the HTML files that they have packaged inside it, you'll start to come across these custom URL schemes that are kind of internal to the app. But because our render window is inside the app, it is also internal to the app. And so in Visual Studio Code, we can run the internal command and tell Visual Studio Code to start a debugger. And I started a Node debugger because Node is pretty built in, obviously. And then you can set some launch args for the Node process that runs. So -E to evaluate, and then whatever is here, what the string that's next, it'll just run that as is. This wasn't fixed for a while. They left it open and told me they weren't sure when they were going to fix it, but I tested in the last version, and this looks like it's resolved. They said it was like breaking too much, and it did require user interaction. You did actually have to click on the link. It wasn't as soon as you preview the file that it would execute. So it was, you know, a little bit more involved, but they had some extra work to prevent JavaScript from automatically clicking the link by testing to see that it was a physical click. So this is definitely something to look for in desktop application. And there was an example of that. There's a weird render error with that link. If you weren't using the markdown for rendering, it wouldn't render the link unless you had it next to an unclosed other HTML tag. But it was working. And the last one is same origin policy. Your file level origin, and that means a lot to different contexts. Like the JavaScript can usually make requests to any domain when it's file level policy, and it can do other things like read local files. So this is a weird example because like it's kind of not a lot of great information in Etsy hosts, but you could read things like .ssh, IDE, RSA, or something like that from your target. And so if I sent you, or if I checked into my company a new README file that had this at the bottom, and then one of the employees viewed that, it would send me their SSH keys, and maybe they're an administrator, and I'm not. So that's what this example is here, and this was possible in Eclipse. This is actually still possible in Eclipse, and it seems like they don't really consider this an issue. But in this video, as you preview the markdown, I'm using run scope, and you can see that the HTTP request comes across, and then you can see the result of my Etsy hosts for that. A couple other things to note: when you start checking apps, check for other ports that the application opens. There was a lot that went on with JetBrains, a lot of back and forth with them. And another thing they had was a built-in API that was just opened on a known port on 63842. You also want to look at the rendered code. When you put a link in place, in the JetBrains attack, they automatically appended magic code to it, but that code is required in your API, but they automatically injected it into all links. So whenever I was testing, I used like an XMP tag, which basically makes all tags render as text from then on. So you put in a bunch of markdown, a bunch of other things, and put the XMP tag, and then it spits them out below. It's also really useful when trying to figure out like a relative path. Sometimes I need to know where the user's home directory is, and or where they're previewing this from can tell me where their home directory is if I want to try to exfiltrate some other important file. If you do a relative link in the file, sometimes they will re-render those relative links to the full path, which will have the user's home path in them. So that was also really nice. And then, I was looking at these IDEs and editors and wondering why none of them were using like the iOS sandbox. And then it started to make a little bit of sense that, the iOS sandbox prevents, or the OS X sandbox prevents you from making external, like calls to external executables. And so a lot of these IDEs depend on calling external executables for evaluating node or debugging or whatever else. So it makes sense that the sandbox restrictions prevented a lot of these apps from being involved there. And a lot of them are open source and downloadable that way anyway, so they try to not be on the store. But it was interesting to look at apps that may just not be possible for them to be sandboxed. I don't know how much time we have, or if you have time for questions. If not, be sure and add me on Twitter, or we could talk about this more. I will be releasing a full blog or document outlining each of these and the version fixes and steps to reproduce, because I know this is kind of a whirlwind of stuff.
So we have plenty of time for questions. We have about 15 minutes, I think. So let's see here. What kind of process do you have for unpacking and debugging an app? For example, Electron. This person's seen a lot of instances with issues when trying to run the app in debug mode, etc.
Yeah, so with Electron, it's actually super easy on OS X. I don't do a lot in Windows, so I'm not really sure. But in OS X, you can like right-click on an application and go to its, let's see. You can go into its contents and resources, and then there's an ASAR file. From NPM, you can install the ASAR unpacker, and you can just unpack the file, and you'll have full access to its HTML and JavaScript. So you can do that and check out like how Slack works and all the HTML and JavaScript that's in Slack, and everything's in there. And maybe it's minified, and you need to reverse some of that, or there's a lot of them use Webpack or whatever else, and there are tools to unpack Webpack apps. But I thought it might be really interesting to build a tool to automatically unpack Electron apps. And then I thought it would be interesting you can attach to running apps with the debugger by its process ID. And it might be interesting to inject some code to enable the developer tool by process ID if you are a privileged enough user. And that might be really helpful to help debug as well. A lot of them, like Visual Studio Code and some of those, you can just turn on the developer tool and use it as if it were a Chrome developer tool as you debug them. And then for the other tools, I wasn't targeting IntelliJ directly, but there is an IntelliJ version that was open source. So go through any of the open source projects and look at the code that's similar to these projects, or when you're attacking open source code, obviously it's pretty easy.
So we had someone ask, are there any books on this topic?
Not that I know of. There were some talks on electrons, like security and identifying electron, I think at some of the more recent OWASP. And there's also the Brave browser project, which was interesting. And they moved away from Electron because of some of its security concerns. But I haven't found much around this topic specifically, but I'm sure there's some best practice or some guides to embedded browser security, which I have mostly been ignored apparently.
Let's see. I think that might be it for the questions that are that were submitted. If for those that are watching right now, if you have any more questions, make sure to throw them in the Zoom. Well, I think that might be it for us, for your, in terms of questions.
Great. I just walked through a couple of examples of the ones I had. I have reported all of these, and most of them either said that there were a no fix or they have updated. So I tried to get as many of the old versions as I could wrangle and try to get a few of these POCs together really quick. But not all the editors, it was easy to find a back version. So.
Hey Matt, one of the I guess comments / questions I have about the whole idea here is that there are tons of web-based WYSIWYG libraries for text editing that go into blogs or just get baked into all kinds of websites and stuff like that. These same principles can apply to those things as well, with like the web hacking and embedding like file paths and stuff like that too, right?
Yeah, absolutely. I mean, any of the stuff that ends up rendered in places like this, it is absolutely relevant there. As far as Markdown goes, I found a bunch of vulnerabilities in just the parsing for the default Markdown parser that's used in Visual Studio Code. So it was possible to inject JavaScript even if they had the sanitize options on, because writing parsers is hard, and there's a lot of ways to inject JavaScript in those as well. So there'll always be attacks on parsers and handlers of parsers, and then renderers and link handlers and things like that.
Cool. Very cool.
Well, thank you, Matt. I really appreciate your time presenting this to everyone today.
Great, thank you.